Welcome to the DIY Honda Garage channel. The DTC P16F4 indicates a low voltage issue in the starter cut relay 2 control circuit. Specifically, this DTC is set when the engine control unit detects that the voltage in this circuit is below the expected threshold. The starter cut relay is crucial for preventing the engine from starting under certain conditions, such as when the vehicle is not ready for operation. This relay is located in the relay circuit board, which is connected to the vehicle's powertrain control module, PCM. It's essential to address this issue, as it can lead to the engine failing to start or other related electrical problems. Diagnosing this issue will require a thorough understanding of the vehicle's electrical systems and the ability to track down low-voltage problems effectively. The starter cut relay plays a fundamental role in controlling the start function of the engine by managing the electrical flow to the ignition system. When the relay operates normally, it allows the engine to start under appropriate conditions. The control circuit for this relay is typically found in the relay circuit board section of the vehicle's electrical architecture. Low voltage in this circuit can prevent the relay from operating correctly, which may lead to the engine not starting or intermittent starting issues. Understanding the placement of the relay and its connections to the PCM is crucial in troubleshooting the DTC P16F4 accurately. The significance of this diagnostic trouble code reflects on the reliability of engine ignition and overall vehicle performance. There are several possible causes to consider when diagnosing DTC P16F4. A shorted wire in the starter cut relay 2 control circuit could lead to low voltage readings, thus triggering the DTC. Another potential issue might be an open wire, which would disrupt the circuit continuity and likewise cause starting issues. Additionally, a faulty powertrain control module, PCM, could be at fault, as it may not properly process the signals required to activate the relay. A blown fuse, especially the critical fuse associated with the relay, must also be examined, as it can prevent the circuit from functioning correctly. Ensuring a methodical approach to check each of these components is crucial for effective symptom resolution. The symptoms associated with DTC P16F4 primarily include difficulties in starting the engine. Owners may report that the engine fails to start altogether or experiences intermittent starting problems. This inconsistency in starting can be most troubling, especially during situations where reliability is critical. In some cases, dashboard warning lights may light up, alerting the driver to an issue with the vehicle's electrical system. Understanding these symptoms can significantly aid in pinpointing the root cause behind the DTC and determining how severe the issue may be. Being aware of these indicators ensures timely intervention before the problem escalates further. The first step in troubleshooting DTC P16F4 is to attempt starting the engine. This initial action helps determine if the engine is indeed operational or if there are underlying issues preventing it from starting. Upon starting the engine, if it successfully starts, the next step is to proceed immediately to step 2 in the troubleshooting process. If the engine does not start, it is essential to move to step 4 instead. This straightforward yet critical step establishes the initial conditions that inform the direction of further diagnostics and can clarify if there is an ongoing issue directly linked to the starter cut relay control. In the second step of troubleshooting, the next procedure requires the vehicle to be turned off into the lock mode. This action is essential to safely reset the vehicle's systems before continuing the diagnostic process. After activating the vehicle's off mode, the next move is to put the vehicle into on mode. With the ignition in the on position, clear the diagnostic trouble code, DTC, using the Honda Diagnostic System, HDS. This step allows the technician to determine if the issue is persistent or an intermittent fault. Finally, it's crucial to check for pending or confirmed DTCs once again. If DTC P16F4 appears, it confirms there is still an ongoing issue that requires further investigation. During the third troubleshooting step, the focus shifts to identifying shorted wires within the starter cut relay 2 control circuit. Begin this process by again setting the vehicle into the off mode and jumping the SCS line using the HDS while waiting for a minute. The short circuit signal, SCS, check helps establish a baseline for electrical integrity. Disconnect both the PCM connector A50P and the relay circuit board connector A8P to proceed with continuity tests. Test for continuity between the designated test points, particularly from the PCM connector A number 23 to the body ground. If there's continuity, it indicates that there's a short in the wires, necessitating immediate repairs to restore the functionality of the control circuit. In the fourth step of troubleshooting DTC P16F4, the examination shifts focus to the powertrain control module, PCM, and its connections. Ensure that the vehicle is in the off mode before additional procedures. Begin by disconnecting the PCM connector A50P for safety during testing. Following this disconnection, the vehicle should then be placed in the on mode. Measure the voltage at the specified test points, namely between the PCM connector A number 23 and the body ground. This assessment is vital to ensure there is appropriate battery voltage present. If voltage is confirmed, check for relevant service information regarding DTCs to ascertain troubleshooting pathways. Should the DTC clear with a known good PCM, it indicates a malfunction in the original PCM requiring replacement. The fifth troubleshooting step involves further investigating potential open wires within the starter cut relay 2 control circuit. Begin by putting the vehicle into the off mode before proceeding with disconnection. Detach the relay circuit board connector A to proceed with continuity testing. Check for continuity between the test points, relay circuit board connector A number 4 and PCM connector A number 23. This testing verifies whether the wire connecting these points is intact and functioning as it should. A positive result affirming continuity means the wire is operational, implying the issue lies elsewhere, leading to the next troubleshooting steps. Conversely, a lack of continuity necessitates repairing the open wire between the two components for restoring function. Step 6 of troubleshooting revolves around examining the fuse associated with the starter cut relay. Specifically, focus on fuse B21, which is a 10-ampere fuse located in the underdash fuse/relay box. Begin this step by assessing if the fuse is intact. If the fuse is blown, this indicates a potential overload or short, requiring immediate attention. Inspect the IG1 ACG wire, which connects the fuse to the relay circuit board, for any signs of shorts or damage. Fixing any identified shorts and replacing the blown fuse is essential for restoring connectivity within the circuit. If the fuse checks out fine, this means the issue could lie elsewhere in the relay circuit, necessitating further checks. The seventh and final troubleshooting step focuses on the IG1 ACG line, connecting the underdash fuse relay box to the relay circuit board. In this assessment, disconnect the necessary connectors from both the underdash fuse relay box and the relay circuit board. After disconnecting these connectors, jumper the specified terminals to establish a test circuit. With this connection, continuity must be checked between the relevant test points, ensuring the integrity of the wire connections. If continuity is confirmed, it indicates the wire is functioning properly, leading to a recommendation to replace the entire under-dash fuse relay box for complete repair. Conversely, a lack of continuity demands a thorough inspection and repairs along the circuit line to eliminate open wire issues. Upon completion of repairs related to DTC P16F4, it is essential to perform a final verification to ensure that all issues have been resolved. The first step in this verification process is to recheck the diagnostic trouble codes, DTCs, using the Honda Diagnostic System, HDS, once more. This step ensures that no remaining faults are present in the system. Additionally, it is crucial to start the engine again after all corrective actions have been taken. Observing whether the engine starts smoothly without any ongoing issues is a key indicator of successful repair. By following this protocol, technicians can confirm the effectiveness of the repair efforts and ensure the vehicle is once again operating reliably. To prevent reoccurrences of DTC P16F4 and associated starting issues, implementing a regular preventive maintenance schedule is highly advisable. A top priority should be regularly inspecting electrical connections related to the starter cut relay and PCM. Loose terminals or corrosion can go unnoticed, but may lead to significant electrical failures over time. Additionally, routine checks of the vehicle's overall electrical system will help maintain optimal performance and reliability. Ensuring connections are secure and systems are calibrated can significantly mitigate the risk of similar faults in the future. These proactive steps not only prolong the life of electrical components, but also enhance vehicle dependability. In conclusion, troubleshooting DTC P16F4, which indicates a low voltage issue in the starter cut relay 2 control circuit, requires a methodical and precise approach. Each diagnostic step outlined, ranging from initial checks to assessing continuity, plays a crucial role in identifying the root cause of the issue. Understanding the roles and connections of various components, such as the PCM and relay, is fundamental in executing effective repairs. Regular preventive maintenance is highly recommended to reduce the risk of similar issues arising in the future. By adhering to these guidelines, technicians can ensure that vehicles remain reliable and operate smoothly. Ultimately, this deliberate and thorough explanation helps illuminate the importance of each troubleshooting stage in resolving DTC P16F4. Please like and subscribe to the channel. See you next time.